What are case classes in Scala? So this is a very important question because case classes are something which we use very frequently in Scala and also in big data applications like Spark. So let's understand what are case classes, right? So case classes in Scala are a special type of class that comes with several built-in features and are designed primarily for modeling immutable data. Okay, so basically we use the case class to model. That means we use the case class to create a schema or a structure. So you have the data, you need to create a structure for that data. That is the primary use of case class. So there are some features of case classes, like case class cannot inherit any other case class. So you cannot have one case class and then another case class inheriting this feature. So that is not possible. It supports pattern matching. We will see that in an example. Now, the other important feature is you don't have to use a new keyword to initialize the case class. So if you're using a simple class, you basically use a new keyword to initialize that class. But in case of case class, you don't have to use this. By default, case classes creates a companion object, right? So, and what are the companion objects? Companion objects are those objects that have the same name as that of a class. So for example, if you create an object by singleton example, that's the name of the object, and your class is also having the same name, singleton example, then we say that the object is a companion object and the class is a companion class. And the advantage is that they can basically use each other's private methods. So that's the advantage of the companion. So by default, case classes create a companion object. All the arguments will be val, right? So val, basically there are two types of variables, right? One is val, one is var. Val is immutable, you cannot change it. So basically case classes are, that's what we saw, right? They are immutable. This is the same thing, they are immutable. They are helpful for modeling the immutable data, right? So we'll see one example. So here's the case class that I have defined. So case class emp, you can see name, city, zip code. Name is string, city is string, zip code is integer. So basically we are defining a schema or a structure, right? And then we have emp1, emp2, which are the instances of this case class. Now if you see here, we are not using a new keyword, we are directly going and initializing this case class emp, and then we are sending some data, right? John, New York, and this is the zip code value. So we created two instances, emp1, emp2, and now one of the features that we've seen, right, it supports pattern matching. So we are doing a pattern matching here, right? So we create a new method, print employee information, and then this is, and its type is of case class emp, right? And then if we are matching if the data that we send it matches with this structure or not, and if it matches, then we are basically printing those data like name, $name. So this is the structure we defined, right? Name, city, and int. So we are basic city and zip code. So basically we are printing those data, right? We are printing this information here. Okay, so let me just remove this. Okay, so this is what a case class is. So let me save this, and I am going to run this now. Okay, so what will happen is we created an instances of this case class. There are two records here, John, New York, and 10,001, and then Kevin, San Francisco, this one, right? So basically what will happen is that it is going to initiate this case class, and then we are doing a pattern matching here, and then if it matches, we are going to print this value. All right, so you can see this data here, right? The output. So name is John, city is New York, zip code, this value, same way we are having this data as well. Now what I will also do is, if we do a emp1 and if you see a dot, so you will see here city, name, zip code, right? So basically this is the data that you have, so you are assigning a structure. So this structure is your name, city, and zip code. So you can individually call this data as well. So if I want just employee1 city, I can simply say employee1 city. I can print this value also. So let me save this first and let me run. So this is where I was talking about the modeling, right? You are creating a schema. So this is an important aspect. You have the data and then you define a schema for it using a case class, and then using the schema, using the structure, you can extract the data. So basically like creating a structure to a data. This structure will then have the columns. You can basically retrieve the data using the columns, just like we retrieve the city data here, New York, for the employee 1 using this method. All right, so this is what case classes are. I hope this was helpful. What are tuples and what is their usage in Scala? Now, tuples are used in other programming languages as well, like Python. So if you're familiar with Python, you will understand what tuples are. But let's understand what tuples is, right? So tuples are basically ordered collection of elements, and they are often used to hold a small fixed number of values of different types. Okay, and tuples are quite versatile and they can store elements of any type, right, including other tuples. So you can create a tuple and one of the element could be another tuple. So that's what tuples are, basically to create or to store some data of different types. So we'll see that an example. So here I have created a Scala class, a Scala object. Now here I have created a tuple. This is how you create a tuple. This is a tuple name. I have given it as my tuple. So you can see different types, right? Integer, string, and double. So this is your integer, then you have a string value, and then you have a double value. So any type of data can be stored in the tuple. Now how do you access this data? So this is number 1, this is number 2, number 3, right? So basically you give a tuple name, you say a dot, and then underscore 1 would be your first element, underscore 2 would be a second element, underscore 3 would be your third element. This is how you are accessing the tuple. And once you are accessed, so here what I am doing is I am basically assigning this tuple values to the variables like first element, second element, and third element. And here also I'm doing a pattern matching. So whichever pattern is matching, that particular case statement will be printed. Like for example, my pattern, my tuple, so my tuple pattern is basically integer, then I have a string, and then there is basically a double value, right? So if you look at this, this is the one which is matching, right? So the first element is 1, second element is this one, right? So this is what is matching. Second case does not match because the third element is number, but here we have double. Okay, so let me save this and I am going to execute this to show you the output. So you can see here, like first element is 1, second element is dollar string, which is hello. So this is how tuples are. You create a tuple, you can have any type of data within the tuple, and then you can access this tuple using a dot notation. Underscore 1 would be the first element, underscore 2 would be second element, and so on, right? So this is what tuples are. I hope this was helpful. So what is the importance of app in Scala? And what is this app and why is it used? So this is a very interesting question. It's not really a very common question, but we have seen in different interviewers trying to ask this question. So basically in Scala, app is a trait. A trait is, if you look at Java, it's kind of an interface. Now this is provided by Scala standard library. It is designed to simplify the creation of small self-contained Scala applications that can be run as standalone programs. The importance of app in Scala lies in ability to streamline the development and execution of simple scripts and applications without requiring the developer to write a main method explicitly. Okay, so let's break this down simply. So basically, when you want to run any Scala program, you have to run using a main method. You need to have a main method. That's the entry point, right? That's the entry point for execution. But if you see in some projects, some developers, they don't define a main method, but then your program actually runs, right? So this is interesting. So let me just go here. So if you see here, I created an object. I don't have a main method, but I can go ahead and run it and it will run, right? Hello Scala program. So I change it. Let's say I add it 1 here, I save it, I go back and I run it, and it will run and it will display me the new data or the new output, which is hello Scala program 1, right? And this is a lot of people, when especially when you are new, you were told like, hey, you without main method you cannot run, but we don't have a main method here, right? But still it is running because of this app. So what happens internally is that this app will internally call this main method, and that's how your program is running. So even if you don't have a main method but you are extending this app thread, your Scala program will run. So that's the main advantage of this. So this is something like some developers will use if you just want to get start, write a small application, you use this app method, you don't want to define any main method. Although this will work, but typically we would not advise or encourage people to use this. We would want to follow the traditional method of main method. But because we have seen some people use this in their projects, and this has also been asked in the interview, that is the reason why we are covering this. So I hope this was helpful for you guys, and I'll see you guys again in my next class. Explain map and flat map. So this is a very important concept to understand, and this is something which is very commonly used in your transformations as well. Okay, so what is map, what is flat map? So map and flat maps are two commonly used higher order functions, right? So they are basically used in the context of collections like arrays, your list, your tuples, right? So this is where you use your map and flat map. So to simplify this, put it in a one liner, what map does, right? So map, it takes a function and applies that function to every element of a collection. Let's say you have a list, you have three elements, 1 2 3. Now you created a function where you are saying that every element that you pass to the function should double, right? So that's where you can use that map. You take that function within the map and you run through the entire list. So that's what we are saying, right? Now what does flatmap do? Flatmap also does the same thing as map. The only thing is, in addition to that, what map does, it flattens the elements. So it just basically breaks down all the elements. So that's the major difference between flat map and map. Okay, so we'll see an example to clarify, to understand things better. So here I have created a package. Now I have a list. So here I am saying numbers 1 to 5, list of numbers. Now what I'm also doing here is I'm creating a function. So this is my function. So this is where I'm using map. So numbers is my list. So I am saying numbers.map. So I'm iterating through this list and I'm passing this an element x. So for every element x, what I'm doing is I'm doing x star x into x. So basically the first element will be 1, and then this element will produce 1 into 1, the output is 1. Second element will go 2 into 2, output is 4. So basically we are squaring the numbers. So we are taking one number and providing the square of that number by passing the logic. So this is a function that we are passing inside the map, right? So and then I'm printing it. And what about flat map? Again, I'm taking a list of strings here, hello and world, and I'm just running through this flat map, each word, and I'm doing nothing here. I'm basically saying word dot to char of array, so converting to char, right? And then I'm printing it. Okay, so this is what we are doing. So if I go ahead and run it, so the first thing is your map, it iterates through the list and it basically prints the square of the numbers. And then your flat map, it iterates through this list and it flattens the data. Okay, so let's observe this. So this is the output of the map. So 1 into 1 is 1, 2 square is 4, 3 square is 9, 4 square is 16, 5 square is 25, right? So this is what map is doing. You take the logic or function, you apply to every element using the map. And flat map, if you see here, hello world, it is being split into individual elements. So this is like you're flattening this data. So that's where, so if you are using any complex data and you want to flatten the data, that's where you can use a flat map. For example, you have a JSON data or an XML data that you want to flatten, this might be very helpful. So two very important concepts. I hope this was helpful, and I'll see you guys again in the next class. So what are higher order functions and lambda expressions, right? So higher order functions are those functions that contain another function in them. So in higher order functions, what we do is we pass another function as an argument or return a function as a result. For example, if you look at this, sub reverse is a function that we created, and we are passing this function to another function which is add 0. This is also another function that we are created, right? So this is what your higher order function is. Very simple, one function into another function, right? So we'll see an example as well to better understand. So here I have a class, some functions which is created. I have two functions here or methods. So if you see here, sub reverse is a function which takes an argument string, and then what it does is it basically substring. We are using a substring for first three characters, and then we are doing a reverse. So you pass a string, that string first three characters is observed, and then you are reversing those three characters, right? Now add 0 is another function. It takes a string and we just concatenate it with 0 0 0. Whatever strength we have, we just concatenate it with 0 0 0. Okay. Now coming to our main method, so we are initializing this class here, and then what we are doing here, you can see here, the first thing that we are doing is we are doing a reverse of Robin. Okay, so let me do one more thing. So I'll do a simple println here, and this is what we are passing, right? So okay, so just to see how the data is, right? So first we want to understand how the sub reverse function is working, and then this data, the output of it is added to another function which is add 0, which basically adds 3 zeros, right? Yeah, 3 zeros. So let me just go ahead and run this, and then we will talk about the lambda function as well. Okay, so let me go ahead and execute this. All right, so this is the data for the first two functions, right? Where is this? Okay, this is the one. So first is sub reverse of Robin. So now what the reverse is, basically what it does is here you can see, right? It takes the first three characters, right? So first three characters is this one, ROB, and then it reverses. Reverse of ROB is BOR. So that is what you see here. And then that data you're feeding to another function where it says add 0, it is adding 3 zeros. So BOR and then 3 0. So that is what your higher order function is. So one function is an input to another function. Simple concept, right? Now lambda function are shorthand notation. So you don't create a function, you just create the logic here. So for example, x star s, right? So what I'm doing here is I'm taking the square of the numbers, right? Now instead of creating a function like this, I can create a function like this and say, hey, x star x, I accept input, and then I'll do x into x, right? Instead of creating the function, I am basically defining this logic here using this one. This is a rocket symbol. So after this is a logic that you have defined. So this is your lambda, so anonymous function. So and then I'm just printing the data, right? So here I'm passing the value of 4, and what it does is 4 into 4 is 16. So this is the output that you get. And this is another example of lambda function where you are basically trying to find the maximum value. You have the if logic present, and you're trying to find which among this is a maximum, which is 41 5 12, and the output is 41 because that's the maximum value. So this is what your lambda functions are. So lambda functions basically are used when you want to just create a very small logic, like this is a very small logic that you want to create, right? You don't have to define a function for that. So for the small logics where you know the number of lines of code is very minimum, just a one liner, that is where you use a lambda function. Okay, so that's your lambda function, and then we have seen your higher order function. I hope this was helpful, and I'll see you guys again in my next class. Explain traits in Scala. Another important question in Scala. So what is trait? So in simple words or simple sentence, trait is a special kind of class that enables multiple inheritance. So using class, you can inherit only one class at a time, but This is where traits comes into the picture. Using traits you can inherit multiple traits at a time. So that's the main advantage of traits, supports multiple inheritance. So basic example, if you look at the syntax, you have trait, then the trait name, and then you have all the logic, you have all the feeds, you have all the methods. Okay, so let's look at an example as well. Here is the trait. This is how you create a trait. So I have defined one function my school. I am just simply printing the data here as my school. Similarly, I've created another trait, and if there's another method that I have created, my college, and I'm printing the my college. So my school will have my school, my college mention will have my college. Okay, and this is where I am inheriting both my school and my college. So you can see here a class my student, this extends school, right? So this extends school with college. So this is the thing, right? So you are extending school with college. So you are basically saying you are inheriting both school and college. So here you create an instance of your class, and then you are saying you are calling. So you can see here my stu dot, my college, and my school, both of them are accessible. They are in different rates, but you are extending both of them, right? So this is how it helps with the multiple inheritance. So if I go and execute it, you can see my school, my college, both of them are printed because we are extending both of them here. Extend school with college. This is your multiple inheritance, and it is only possible using traits. So that's the main advantage or the importance of traits. It supports multiple inheritance. So that's all for today. What is the advantage of companion objects in Scala, right? So first of all, let's understand what is your companion object. So companion objects are those objects that have the same name as that of a class. So saying simple terms, right? Simple thing. So if you have a class, let's say your class name is singleton example, your object name is also singleton example, then we say that both are companion to each other. The object is called as companion object, class is called as a companion class. So what is so special about it? What is the advantage of it? So companion object and companion class can use each other's private variables, right? So this is one thing which is very different with normal classes or objects. So if you have a private method, they are only accessible within the class. But if your class name and object name are same, then you can use each other's private method. So we'll see that in an example as well. So here I have defined a class companion object example, and if you observe here, right, the object name is also companion object example. So both of them are having the same name. So I defined a private variable age, and I have defined a private function hello, right? And now I am creating an instance of this class here, and if you see here, s.age. So age is a private variable. Hello is also a private function, but I am using both of them here, and if you run it, you will see that we are able to print this data. So age is 32, you can see it here, and hello Robin is the definition we are using, and hello. So using this companion object, we are basically able to retrieve or use the private methods or variables of your classes. So that's the advantage of your companion object. So I hope differentiate between val and var in Scala. So very important to understand, very basic thing to understand. When you're declaring a variable, you can declare it as var, you can declare it as val. Okay, now this is very important to understand. They are not same, they have a very slight difference and a very important difference. Okay, so val and var are two keywords used to define Scala variables, as we just mentioned, right? So var keyword is basically very similar to how you use in Java. Val is something which is very specific to Scala. So what happens? So once you define a variable as var, okay, you can change its data at any time throughout the execution. So let's say I define var a variable, let's say var a equal to 10. Now throughout the execution of the program, somewhere down I can change that value of a to 20. Okay, that is a normal scenario in any programming languages. So you have a variable, you can change that variable name any or value anytime, right? That is your normal behavior of variable, that is var. Val, what happens is that when you change if you define a variable as val, you cannot change its value again. So it is something like your final keyword in your Java program. So if you define something as final, it's constant, it remains the same, you cannot change it. So that's the difference between val and var. If you want a variable to be constant, use val. If you are going to change the value of the variable, then you will use the var. Okay, so let's see an example as well. If I do a simple val a equal to 10, right? So this is cool. Now if I try to change this, if I say a equal to 20, you can see here, right, there is an error. It's a reassignment of to val, so this is not possible. However, if I change this to var, you see the error has gone. You are defining a value and then you are changing it. So that's the basic difference between val and var. So okay, another important question in the interview is, what is the difference between method overloading and method overriding? Okay, so we'll look at an example, then we'll understand the difference, right? So first thing is method overriding. So I have defined a class parent, I have a method called as hello. So observe this, right? Hello, it has one variable which is string name, right? And I am extending this parent class here using extends, and what I'm doing here is, if you look at this hello name, I'm using the same variable, nothing is changing, right? I'm using the same function. I have hello here, it has one argument, here also we have one argument, and if you see here, we are using something called as override. So what it means is, you have a method and somewhere down the line you want to override the original functionality. For example, here this method is saying hello name and this method is saying hello my name is. So the logic is a little different, right? A very simple logic. So down your code, somewhere in your code, if you want to reuse a method but you want to override its logic, right? So you want to override its contents, then you use the concept of method overriding. Simply you say override here and then it will override whatever the method is here. So now when I execute this, I am creating a new I am initializing the subclass and I'm calling the hello method. So what will happen here is that you have two methods. One is in the parent one, which is hello name, but then again you are overriding it here saying hello my name is. So that's what your method overriding is. It overrides previous methods. You can base this is simple logic that I've written, but we can use any complex logic here as well. So if you want to override the method, then you use a method overriding concept. So next we want to talk about method overloading. So similar concept, but here if you see, the method names are same, arguments are same, right? Here the method is same, you have an add method, here you have an add method. So what is different here is that the number of arguments are different. So if your method name is same and the arguments are different, then you will say that it is method overloading. So you have two arguments here and you have three arguments here. So here what I can call is, I am calling this method and I'm passing two arguments here. I'm calling the same method, I'm passing three arguments here. So if I execute this 10,20, it will call this method and it will print the data value, which is a plus b. So I'm giving 10 plus 20 is 30, and here I'm calling 1, 2, 3, 3, 4, 5, 6. It will call this method and it will print the value, right? So this is what it is, this is the difference between method overloading and method overriding. Method overloading is same method but different arguments. Method overriding is same method with same arguments, but you are overriding the concept. That is all we have. I hope this was helpful and I'll see you guys again in my next class.